All right. I guess I'll just preface this by saying, are you guys like familiar with LeetCode? Like, you guys do LeetCode? Yeah. You guys okay? You guys do that? Okay. So I'm assuming if like the people who do LeetCode, this problem looks very familiar, right? Yeah. Like twosome. You guys know how to do twosome? Because I don't want to like go over problems like because I know there might be some like uh there's some difference. Like some people might know this stuff, some people might not. So if like I'll probably start with this because I know you said you're not that familiar with LeetCode stuff. So yeah, so if if anybody like knows a solution or something and like wants to give insight at any times, sure. Uh, but yeah, it's 12:15 now, so I guess we will start. So does everybody have like a LeetCode account? Yeah, good. Like something you don't even need one. You can just follow along. All right. So let's look at the problem, right? So we're given an array of integers, nums, and an integer target. We want to return the indices of the two numbers such that they add up to the target. Now, we may assume that each input has exactly one solution, and we may not use the same element twice. All right, so we can look at example 1, right? So we have an array of 2, 7, 11, and 15. And this is going to return us 0 and 1 as a subarray, or just an array. And this is because the values at index 0 and 1 are 2 and 7, which add up to 9. Okay? So this would be a valid output for this one. And so now we also have this input, 3, 2, and 4. So I guess I'll just ask you, like, which indexes would we want to return in this case? Sorry about that. We want to. Okay, yeah. So like the numbers 2 and 4, right? Those are the numbers that add up. So what index are these numbers at? 1 and 2, right? So we're gonna be returning 1 and 2. Okay. So so now we understand the problem, right? We understand the examples. Okay, the output. So these are the constraints. Okay, so a legal problem is always going to have constraints at the bottom, and the constraints, you might gloss over them at first, but they're actually very useful because, first of all, they'll tell you what type of problem it is, right? Because, for example, let's look at this, right? These are really big numbers, right? Like look at the length of length of this array, like so this in particular, okay? This is a really big array, 10 to the fourth power. That's big. That means that are you guys familiar with time complexity? Okay, so 10 to the fourth, right? So with this means that our time complexity shouldn't it shouldn't be crazy big, right? So like we're not going to be getting like something like n factorial because that's like backtracking or something, and like that would be way too big for this problem. Okay, so we know like it's not going to be as bad as n factorial. So like we can think like, okay, maybe it's linear, quadratic, something like that, right? And also this part, exactly one solution exists, so you don't have to think about any special edge cases where you need to return like nothing, right? So let's think about this, right? So you guys probably remember this is HashMap, right? So you guys know, okay, there's a HashMap solution to this, but before we get to HashMaps, let's think about the brute force, okay? Because ideally, right, like this is a very popular problem. Everyone knows this problem. Everyone knows the solution to this problem, okay, for the most part. But the way here is you don't always want to do optimal because in interviews, let's say you get a problem, right? But you don't know how to do it, right? What is brute force? Brute force is the most intuitive way to do the problem, right? And ideally, you want to get code out first and like understand the problem, and then what you want to optimize later, right? Because you don't want to be stuck in a spot where, hey, like there is an optimal solution here, and I know there's an optimal solution, but I don't know how to do the optimal solution, so I'm just gonna spend my entire time trying to write this optimal solution where where you don't really know, right? So brute force it first. Okay, so let's think about the brute force. Okay, so does anybody have any, idea of how to approach this with like, we don't care about time or space complexity. Let's just try and get a working solution out. Does anybody have any ideas? So I guess I'll just open up a problem here. I should have cleared my thing, but yeah. Oh yeah. Also for the reference, I'm using Python. Uh, so I guess I'll be talking more about algorithms. You guys can follow in whatever language you want, but if you need any syntax help with like Java or something, you're probably better just searching it up because I'm just a Python guy. But Yeah. So let's look at this problem. Okay. So does anybody have an idea of how we could just brute force this? Mm-hmm. Right. Exactly. Okay. Right, right. That's really easy, right? Because let's say, okay, so we know we only want two numbers, right? So what is that? So like you were talking about, right? One for loop to go through every single element, and then we can have another second nested for loop inside, right? That checks every element too. And basically, we're basically checking, in this case, right? We're gonna be checking 2 and 7. So okay, we're starting at this 2, right? So our brute force is gonna be starting at this 2. It's going to be moving. It's going to look at the 7. Then it's going to look at 11. Then it's going to look at 15. And then 7, 11. Then it's going to be 7, 2, 11, 15. So stuff like that, right? So that's what our program is going to be doing. So that's the brute force. Our program is going to end at 2, 7 here because when it finds a valid solution. So let's write this out, right? So there's no special edge case we have to account for, right? The arrays are such that a solution always exists. Okay, you just have to return one solution, right? So we can have so I'll do it index based. So for I in range, so we want to go the length of the nums, right? We want to go throughout the nums. Now, okay, for this second for loop, where should we start and where should we end? So you remember how I said we want to basically check like one above the number we're at because we don't want to let's just say the target's 9 or let's say the target is 6, right? And let's say there was like a 3 here. Do we want to return 3 twice here? No, right? Because we're repeating elements. We can't repeat elements, right? So where should we start and where should we end the second for loop? So let's think about this, right? So this I is starting at 0, right? So this is gonna be checking that. So we always want this j to be one ahead of where we checked, right? Because we don't want to check the same element twice, right? Because if we started at let's say 0, right? Like let's just say we did something like this, okay? Length of nums, right? Then this would get into the scenario if like let's say we have value 3 at index 0, okay? And our target is 6, then it's gonna be checking that twice, and then it's gonna return that. It's gonna return 3, 3. We don't want that. We want unique. We want unique numbers, right? Unique indexes. So we're going to be going the length of the numbers, right? But we want to be exactly one above of where we're starting, right? So I'm not sure if you guys are familiar with Python, but for Python, this is exclusive, and then this is where you start. So this would be inclusive. So that's where we're starting there, right? So now we have the solution. So now we're iterating through both of them. We're finding I and j. Okay. So now what are we checking inside this for loop? Exactly, right? So if nums I plus nums j is equal to target, we would just I usually do it one lines, but I'll just do it multiple. So what do we want to return? The indexes, right? So just I and j. Okay. So yeah, so this is a valid solution. This runs, right? We can run this. This is gonna pass this. I say we can submit this. Okay? And this will pass, this will end up submitting. But I'll show you this, right? If you look at the runtime, it's really slow. Can anybody tell me? So you guys know about time complexity, right? So can anybody tell me the time complexity of this program? So think about this, right? So it's going through this first for loop, right? This first for loop. So that would be O of n, right? Then we have the second for loop. It's nested, right? It's going inside and it's hitting all the elements twice. So every element gets hit twice, right? So it'll be O of n. Exactly. O of n times O of n. O of n squared, right? That's quadratic. Now let me just bring this up. Time complexity cheat sheet. So I just want to give you guys a visual example of what's happening here. So let's look. Let's go to images. Okay. So this is what it is, right? So we're O of n squared, right? That's this one. Okay. that means that our program gets it keeps on getting bigger and bigger and bigger, right? That's bad. It's really slow for this, right? Like some problems, time complexity, it's just what it is. Like if you guys have taken 211, when you did Waxman's 8 queens, like you went from n to the n power to n factorial, which is a lot better, which is still slow, but it's a lot better, right? So this is n squared. Okay. Does anybody have an idea of like space complexity of this program? So do you guys know what space complexity is? Okay, yeah. So space complexity is basically how much space are you like reallocating to a program, right? So let's say I make this, right? Okay, let's say I do something like this. Let's say I make a new list, right? Let's say I say uh nums2 is equal to nums. Okay? Something like this. I'm basically making a new array, right? Like I'm making a new array and I'm populating with this, right? So with this in mind, our space complexity would be the what? It would be the size of nums, right? Because we basically made a new nums array, right? So what's the size of nums? As it's just n, right? It's a variable, right? N. So our space complexity would just be O of n, right? So here we're not really doing anything like that, right? We're just doing everything in place, right? So with that in mind, we're not creating any new space. What's our space complexity? It would be 1. Oh, constant. We're doing everything in place. We're not making anything new, right? So this our space complexity is O of 1, which is good. Okay. So we have a n squared times O of n squared. So I'll just put a comment, right? So we'll say time is O of n squared. Space is O of 1. Okay, so we have this brute force solution. Now, obviously, looking at this is pretty intuitive, right? This is like you're like, oh, this is like 111 stuff, right? So yeah, and that's what this is, right? This is like the intuitive way you're gonna do it when you do LeetCode for the first time. But you guys are here for like hash maps, right? So do you guys know what hash maps are? Yeah. So can anyone like describe some properties of hash maps that might be useful in this problem? Okay. So hash maps. Oh, you wanna go? What happened? Uh, no. So hash maps. Okay, so what you're thinking? So like FIFO, first and for that's a queue, right? So yeah, this isn't a queue. So hash maps. So the reason we use hash maps is that so are you guys familiar with like web development? Like you guys know what JSON files are? Yeah. So like a JSON file is just a dictionary, right? A hash map is just a dictionary. Okay. So there's keys and values. Okay. So the reason we like hash maps is because it's instant lookup. Let's just say like in Python, right? Let's say I say if one in nums return like true. Okay, this would be going basically this line of Python. It's going to be going throughout the entire nums, and it's going to be checking is one there, right? So it would be checking every element at least once, right? In that array. So worst case, like it's at the end of the array, meaning that it's O of n, right? But with a hash map, let's say nums is a hash map. If we say if one is in nums and we're looking for a key, that would be O of 1 instant lookup. We can quickly look it up, right? So that's really fast. That's good. Okay. So with that in mind, right? How can we make it so that this program, like we can optimize this, right? Like how can we get this to a better time complexity? Let's say we don't care about space, okay? Like space can become O of n, right? How can we get this to a time complexity of O of n using a hash map, right? So let me comment this out. So let's just that. Okay. So yeah. So okay. So this is how you create a hash map in Python. Okay. So I'm just gonna call it mapping, right? It's just a dictionary. It's curly brackets. You'll see this when you work with JSON and stuff. Okay. So we have the mapping. Now let's say. So okay. So now we have this, right? What do we want to populate our hash map with? Okay. Let's say. Okay. So let's think about this. Let's look back at the problem. Okay. So with our double for loop, right? What are we doing? We're checking every element twice. But be honest, do you think think about it? So let's say let's look at this 2, right? Let's say we look at this 2. Okay, we move on, right? Do you think maybe it's a good idea? Let's probably save that. Like let's save the fact that we've seen that 2 in the hash map because think about it, right? if let's say this, right? So we want two numbers that add up to the target. So let's say we take this first number 2. Okay. So what is 9 minus 2? What is the target minus the first number? So what's this? What's the target minus the first number? What's 9 minus 2? 7, right? So wouldn't you think it's a good idea? Hey, if we save this 2 as a key in our hash map, and then we save its value as an index, can't you say, hey, 9 minus 2, that's 7. Have we seen a 7 before? Okay. If we've seen a 7 before, then we can just return true, right? So let's do that drawing with the program, right? We start at this 2. What's 9 minus 2? 7. Okay. Have we seen a 7 before? No, right? So let's move on. Let's save that. Let's save that 2 with an index of 0. Now let's move on to 7. What's 9 minus 7? 2. Have we seen a 2 before? Now we can just return that, right? And look, you see, we're only getting up to like here, right? But let's say our target is, let's do 7. What's 7 plus? Okay, let's say 18 in this case, right? So let's say we get up to here. What's 18 minus 2? That's 16, right? Have you seen 16 before? No. Okay. What is 18 minus 7? That's 11, right? Have we seen 11 before? No, right? And let's move up to here. 18 minus 11, that's 7. Have we seen 7 before? Yes. Now we can just return that. So you guys understand what we're doing? We're just saving everything we've seen before. Instead of here, what we're doing is we're basically checking every single possible combination that that's like that could be valid. We're basically we're being smart about it. We're just saying, hey, okay, we've accounted this number. Let's save this number because we know that it's just basic math, right? So like if we say this, right? If we say x plus y is equal to z, right? And x, so these two numbers, so this is the target. So let's say this is the target, right? So it's just pretty basic math, right? So we can just say target is equal to, what? Like, so we can say what? Target plus x is equal to y, right? Like because we can just subtract on both sides. So, or target minus x, sorry. So basically all you're doing is you're just doing that, right? So okay, so now let's use that in mind, right? So for I in range, so length of nums. Okay, let's go through that. So yeah, so how do we calculate the difference between the two? Remember what we're doing? We're doing target minus the current number. So how do we represent that? Let's store that in a variable, right? Let's call that a difference, right? So how do we represent? Like, what are we doing? Does anyone want to like? Okay, yeah, exactly. Target minus nums of I. Okay, this will give us the difference, right? So you remember how I was saying? So some properties I have as you can just quickly look up, right? So let's account for that, right? So let's just say if the difference is in our hash map, right? That's what we're doing. So if is it in mapping, right? Then what do we want to do, right? So now we can just return. So we can return I, or we can return mapping diff. Now I will. So there's this, right? So now let's say what are we populating? So now this accounts for the return case, right? Now let's populate our hash map, right? So what do we say when we want to save in our hash map? What do we want to put in our hash map? We want to store the values and its indexes, right? So let's store the value in the indexes. So we can just say mapping, right? So we can say nums I, it's the value, right? Is equal to I. So we're basically now we're populating it. So this is what this is doing. So we can run this, right? This is going to run, okay? this is the most optimal solution for this problem. But now let me explain what this is doing, right? This line, we create our hash map, okay? We create our dictionary, okay? We're iterating through each number in the array, okay? We're getting 2, 7, 11, 15. We're getting the difference. So the current number we're at, we're getting the difference, which is the target minus nums I, right? And we're basically saying, hey, have we seen that difference before? Okay? Have we seen that difference before? And if we have, we want to return our index. And this mapping diff, right? What is this? Mapping diff is literally just, it's getting the value, right? Which is the index. Okay? And then this is populating it. So now we're like, okay, so let's just say we diff is not in mapping, right? If diff is not in wrapping, right, we're going to get over here, and it's just going to populate. So now it's going to say map. So like in this case, right, it's going to just say, so our hash map is going to be like 2, And does anybody know what the index of this 2 is? 0, right? So we're saving that. So it'd be 2, 0. Okay? So then it would just, and then it would keep on going. It would keep on going. And if it, once it returns, right? You guys know when you return something in a function, your function ends. Okay? So like, okay, so then we have this now. So this works, right? We can submit this. Okay? And this will run. This will beat our time complexity before, right? It beats 100%. Remember, we were only beating 18% before, and we had like a 2,000 like it took 2 seconds for our program to run. Now it's 0. It's fast. It's a lot faster because we literally went from what? We went from O of n squared to O of n. We went down here. That's so much better, right? We just by being smart about it, we saved it. Okay, so that's what hash maps are. So this is a very popular problem. A bunch of companies always ask this problem. There also ask variations. Like this summer, I'm in incoming software engineering intern at Bloomberg, and for my first round, I was asked like a variation of this problem. If we have time, I'll show you guys the problem and I'll walk you through it. It's really similar to this, but it kind of builds off the next problem we're gonna do. Does anyone ever understand this problem? Does anybody have any questions? No questions? All right, we'll just move on. All right, yo. For the difference we started for the you explain that for the difference thing. We're trying to find this let's see. We're trying to get the sum, right? The 9. Right. So we in this half map we're finding the difference of the target, the nums. It's like while we do that, it's like it checking which numbers will be optimal for the for the target value, right? Exactly. So the reason we're checking this is because think about it, right? Remember what we were saying? We're saying, hey, let's save the numbers we've seen before, right? So if we, okay, let's say this, right? So target minus nums I. So we can literally just say, hey, nums I plus whatever number is equal to target, right? So nums I plus diff is equal to target, right? So, and remember, we care about nums I and the difference, right? Because they add up to the target. So what this is doing is basically this, it's saying, hey, we know that the target minus the current number we're on, okay, that's going to be adding up to the target. So let's save that, okay? So, and then here, this is where we check. This is where we're checking. Hey, is that difference in math? Have we seen that difference before? If we've seen that difference before, then we found a valid solution. The value at I, and and we've seen the difference before, and we know its index. We can just add those together to get a target. Hey, we should just return that, right? And then here, this one is just populating the hash map with what we've seen before. The value mapped to its index. Okay? Does it make sense? Okay, so let's try the next problem. Has anyone seen this problem before? Like a LeetCode problem? What? No, I see. Okay, so I purposely changed up the wording on this just to throw you guys off of it. So yeah, okay. So let's think about this. Okay, exactly, right? Yeah, exactly. So yeah, that's why I did this, right? Because in interviews, I'll tell you right now, they're gonna switch up the problems. You're not gonna get, like, most of the time you're not gonna one-to-one problem, right? You need to be able to recognize that. Like, so looking at this, you see permutation, you're like, wait, is this backtracking? But just like look at the output, like read the problem, and you're like, oh, this is valid anagram. So do you guys know what anagrams are? Yeah. Do you guys know what anagrams are? Or it's literally just a permutation in this case, right? So like we're gonna look at the same thing. A permutation means T contains the exact same number of characters, but possibly in like a different order, right? So we have this example, this output, okay? So like LeetCode and code leet, right? So there's this possible solution. Okay, so we have this. Okay, so basically this is, so why is this returning true? Does anyone want to just like give it like explanation why you think it returns true? It's the same number of characters, right? So if you were to go through LeetCode and if you were to go to code leet, you would end up finding, hey, these are the same number of characters. So let's just do that, right? So let's say S, okay? And let's say, so S will have this, right? So let's say this. S is going to have, so how many times does L occur in Leet? Just once, right? Okay, and then you know what? I feel like this. Let's do this one. Let's do rat and car. Okay. So okay, this one is not an anagram. This one is not an anagram, right? Because look, you can see here, right? Base case right here. You can see like this has a character that the other one doesn't. So look, well, which character? So this has a C, right? Does S have a C? No, right? Meaning it's not one to one. It's not a valid anagram. Okay. So let me just go to a problem and we can just talk about that there. This is also popular. You know the permutation. So valid anagram is a popular question. The permutation thing that I changed up. That's Capital One actually asked that a lot. So there's that. But yeah. So yeah, valid anagram, right? What is an anagram? An anagram is a word or phrase formed by rearranging the letters of a word or phrase using all the original letters exactly once. Okay. So let's look at this first example. Okay. For example, we have let's look at anagram, right? So S is equal to, so A, how many times does A appear here? A appears 3 times. Okay. N appears once. G appears once. R appears once, and M appears once. Okay. So this is S. And now let's look at T. So T is gonna look like, you know, occurs once. A occurs 3 times. G occurs once. R occurs once. M occurs once. So if you guys, so the ordering might be a bit different, right? But you guys see like everything, it's 1 to 1, right? Like everything, A appears 3 times in both, G appears once, and whatnot. So this is returning true, right? So, so you guys kind of see like, how did I write this? I wrote this as a hash map, right? Like you guys see the curly brackets. So let's use that to our advantage. So okay, let's introduce edge cases, right? So TwoSum didn't have an edge case, right? Because it literally told us, hey, you know, there's always gonna be a valid output, right? But this, we do have to account for like a quick little edge case. It's just a quick little fact where we can just check it in the start and we can just basically terminate our program really fast. Like we don't have to do anything, right? So does anybody have an idea? So you remember how we, like, based on the definition of anagram, what is something we can just quickly check and just return false if it's not an anagram? The length, right? If they're 2 different lengths, then you just want to return false. So if length of S does not equal length of T, you can just return false. Okay? That's the first thing we just want to check. Okay? Now let's talk about the hash maps. Let's talk about, so what is this? So this is called a counter, right? It's a really popular thing. Just like Python literally has its own import for this because it's used a lot, right? But I'm not gonna use the import because that's cheap. I'll show you guys just how to do this, right? So how do we make this, right? Let's iterate. So okay, let's first create our first mapping. So there's multiple ways you can do this problem. I'm gonna just do the optimal way from right off the bat because I feel like the optimal way is still intuitive and it doesn't really matter. But so okay, so let's say we have this mapping, right? So we have this first mapping. We want to populate this with S. So how would we want to do this? We want to iterate through S, and then we just want to basically, so here. So for char and S, right? We only care about the characters. So if char is in our mapping, meaning we've seen it before, right? Then we want to just do something like this. Mapping char plus equals 1. We want to increment its value by 1. If we haven't seen it before, what do we want to do? We want to just turn it into 1, right? We want to initialize it to 1. So mapping char is equal to 1. So this effectively gets us our hash map. Okay? This is going to give us our counter. Now, let's think about this, right? So what can we, so now that we have this hash map, we only need 1 hash map. We can use 2, but there's no point. We can just do 1. And I'll explain to you why. Think about this, right? If it's a valid anagram, if we go through this string and let's say we subtract 1 from everything we've added up so far, our hash map should be empty, right? If we have subtracted everything once and like everything is 0 and we got through the array nice, or we got through like the string nice and now our hash map is 0, that means that, hey, it's a valid anagram. We can return true from there. That's good. right? This would just so now let's do that, right? So for char in t, okay. So okay, first now we can just check this first little edge case in here, right? If the character is not in our mapping that we had before, it's not an anagram, right? Because now it's not one to one. So if character not in mapping, what do we want to do? We can just return false. Okay. Otherwise, we can say mapping char, and you remember how we incremented this by one when we were building it. Now let's break it down, right? So now let's subtract. Okay. So now, so this one's subtracting. Now let's just do the one case, right? So so this hash map, let's say so right now it can go to negative numbers. So let's say there's S had 3 A's, but then T had 4 A's. Right now, our thing would keep on subtracting, and it would just end up becoming -1, right? But we don't want it to get to -1. Once it gets to 0, right? We want to just get rid of it. That means that okay, we have this now. Our goal right now is to turn our hash map into nothing, right? Get it to 0. Okay, so we can just say this, right? If mapping char is equal to 0, what do we want to do? We can just delete it from our hash map. We don't need that because okay, now we've gotten to a point where hey, when we delete it, right? Basically, it's gonna go up to this because once we delete it, let's say we encounter another A, that means that okay, A is no longer in that hash map, meaning that it's not one to one. Return false. Okay, so we can do that. So if it ever equals to 0, we can just delete it, right? And now after we've done this, what do we want to do? So now this has effectively just like broke down our hash map. Now what do we want to check with our hash map to like find whether we want to return true or false? Any ideas? Okay, so I'll just tell you guys, right? So you can just return whether the length of our hash map is equal to 0. It can, because think about it. Now, if it's equal to 0, right? What is that going to do? It's going to return true, right? If our hash map is nothing, like in this case, right? We went through S, we built this table, okay, and then we're going to go through T, and then we're going to subtract 1 from every single time. And ideally, our hash map now is going to look like this, right? It's going to have a length of 0. There's nothing in it. Okay, and if there is something in it, that means that it's not a hash map. It's not valid. Oh, it's not a valid anagram. So this will just return true or false. So if the length of the mapping is equal to 0, we can just return true. If not, return false. This is called like list comprehension in Python. So we can run this. So yeah, this runs, and this is the most optimal solution for this problem. There is a different way you can do this. We're making two hash maps. You don't. You could do that, but like, and it. Okay, so let's talk about time and space complexity here. What is the time and space? Like, okay, what is time complexity here? Does anybody have any ideas? Yeah, yeah. So here, what would be the time complexity? Like, n, y n. Okay, but we have s and t. So if I actually okay, we have two different strings, right? So would you say like what? It'd be 2n, right? But like we don't care about that too, right? So this so what I was thinking. So this first if statement, basically it makes it so that our strings are going to be just one length, right? So s and t are going to be the same length no matter what. Okay, so it's like if they're not, it's never going to get to a point where it's checking different strings, right? So actually, yeah, exactly. It'd be 2n, right? Because there's this first for loop populating, that'd be n, plus this one, t, which is n again, so 2n. But we don't care about the 2's, right? We don't care about the coefficients and the constants. We just drop that and we care about n. So yeah, this program, our time complexity here is n, right? Does anybody have an idea of what our space complexity is with this hash map? And I'll give you a hint right over here. Oh, not this. This. It would be over one, exactly, right? You might you ex- exactly. So like worst case, what is the biggest our hash map can get? 26, right? 26 lowercase characters, right? So, but 26 is still a constant. So anything that's just like a number, it could be you could have 1 billion, right? But that's still a constant. So it just dropped to O of 1. Okay, so our space complexity here would just be O of 1. And and I mentioned there was a different way of doing this problem where you can have two hash maps. And literally the idea is literally just take this code, but like do it for t again, and then you can just return whether those two hash maps are identical. You can just return mapping s equal mapping t, and that program our space and time complexity would be the same thing, but okay, but it would be O of our space would be O of 26 plus O of 26, which is O of what 52, but that's still O of 1, right? But like this is just a better way of doing it. Like they're probably gonna ask you like, hey, like this would be a follow up in interview. If you did that first, if you did that way I just talked about, there's a hey, can you do this with just one hash map? And then there's also a follow up here, right? What if the inputs contain Unicode characters? How can we adapt? So how can we adapt the solution for Unicode characters? Any ideas? Okay, it's a trick question. We don't have to. Like our program already adapts for that. Because our hash map, but then our like would our space complexity change? No, right? Because even if you have like Unicode, I think there's like there's a finite number of Unicode characters. There's no like crazy amount. So and our hash map can only have unique elements. So we can't have multiple elements, right? And since this is a counter, it's just gonna be incrementing if there's more than one. So yeah, our code already accounts for the follow up. So yeah, this is a valid solution. This is the optimal solution for this problem. Uh, so yeah, these are pretty basic problems. I came here with like more. I came here with harder. I came here with my Bloomberg questions from my interviews. That's actually the next question. It's like the two sum variation I got asked for Bloomberg. This is the starting one. Uh, this one, the reason I actually two sum and valid anagram is because this is literally just a combination of the two. This like you see how valid anagram was like a frequency map, and then two sum was an indice map. If you read this problem, right, this problem, it's literally two sum but using a frequency map. Like that's all it was, right? So if you look at this output, like it's our valid pairs are 1 4 2 3 2 3 3 2. So like okay, we're not gonna write any code, right? We're just gonna talk about this problem. How would you guys like do this? Just brute force using two for loops. How would you guys do this? Yeah, this question isn't on LeetCode, by the way. Okay, yeah. See, so I see what you're saying, right? I in my interview I said the same thing. I was like, oh, we can use a set, but we care about how many times we've seen the previous character. So let's say this, right? So let's look at this. So let's see. So 1 and 4, these make a valid pair, right? So let's think about the brute force approach. This problem. So let's start this first number and let's check every number in front of it. Okay, which numbers here add up to 5? Like with this number, it'd be 4, right? So that's one valid pair. Let's move here. Okay, it'd be this 3 for this, and then nothing else here. Robin? Yeah, 2 and 3. This 2 and this 3, and then nothing else from here, right? And then let's go here. Okay, it'd be this 3 and this 2. Okay, uh, and then now let's go over here, right? Now we have this 3 and this 2. So you see how we have 4 valid pairs. Okay, but if you use a set, you I don't think maybe this example doesn't account for it, but like you yeah. So you just want integer. You don't have to return like the actual. What happened? No, because there's multiple. There's different. We're still using different elements. We're not using the same elements. You see how there's multiple 2s and 3s here? Yeah, we're using different elements here, right? So like for example, this 2 and this 3 are not the same as let's say, or let's say this. Like this 3 and like this 2 is not the same as like the other way around. Like it is the same, but it's like this 2 and this 3. Exactly. So this one, I'll just write the code like out here. So this is the brute force, right? So for I, we don't even need. So okay. So first of all, we'd want to have a global variable, right? So we can say res is equal to 0, right? So we can say for num and nums, or we can say for I in because we care about the siren. So let's just say for I in range length of nums, right? And then we can say here for j in range, same idea, right? We want to do I plus 1, and we're going to go length of nums, okay? And then we can just say if nums I, I didn't create the function, but yeah, I'll just quickly make the function. So also, yeah, during my interview, I forgot to make the function, but the guy was cool about it. So we can just do, res plus equals 1, right? I'll stop doing these single lines because it's just so convenient. But okay, so get rid of that. Our function would just look like def so, and we can say target, and then well, I won't do the other stuff, but so this so this is the brute force for this problem, right? It's really similar to like the brute force for uh two sum, right? But now I'm just gonna show you guys the optimal the hash map solution, okay? So this one we can make the happening, so we should just make the hash map, right? Then we can say res is equal to 0. Now we can say for num in nums, okay? We have the same algorithm. Diff is equal to target minus num, okay? And then we can just say this: if diff is in mapping, we can just say res plus equals mapping diff. And then otherwise, we can just say, so this is a handy little Python thing. You can say mapping num is equal to mapping dot get num 0 plus 1. This is literally just populating the hash map. This is basically saying, hey, if we haven't seen this number before, let's initialize it to 0 and incrementing to 1. And if we have seen it before, let's just add 1. So this is just really not cheap way. It's really convenient. But yeah, this is literally the solution, and it it may seem like once you see the code, you're like, oh, it's obvious. But yeah, I had the same idea. Is we need the set, right? But the set doesn't. We actually care about how many times the number has appeared before, right? Because let's just say 3 has appeared before, like four times, right? And we have like a 2, and our target is 5. We want to be able to basically that 2 can make a pair with any of the 3, like any of the number of 3s we've seen before. If we just had a set, it would just do it once. We need to track the occurrences, right? So that's what this program is doing. And then my next follow up was, how can we do this? So the time complexity and space complexity is O of n, O of n. How can we do this better than O of? So space has to be O of 1. Time complexity has to be better than O of n. This isn't a hash map. Time complexity has to be better than O of n squared. This isn't hash map, by the way. Yeah, better than O of n squared. And space has to be O of 1. So that would just be 2 pointers. It would be if you sort it. Yeah, if you sort it, then you can use that to just, if you find a valid solution, you can increment your thing by 1 and then move the pointers in. And then if not, you can just basically move it so that you inch closer to a closer solution, right? So that would be the O of n log n solution, because sorting is O of n log n, right? The Python's inbuilt one. So that was this problem. This was my first round for Bloomberg, and I guess if you guys like come to the next one, I think I'm doing 2 pointers. I'll show you that intuition. We didn't get to this. This isn't a bad problem. It's a LeetCode medium group anagrams. This question was my final question. Was one of the questions I got on my super day for Bloomberg. Uh, this is pretty unintuitive. It's using basically a hash map like you guys can be right. You're designing a lottery system that allows players to enter, leave, and get a random winner in constant time. You have to implement these in O of 1 time complexity. If you doing an O of n, that's really trivial. You can just remove. But O of 1, you gotta use hash maps. And this is kind of just a funny thing. If you ever get like a design question and like there's an optimal solution that they're looking for, throw a hash map at it. Like I guarantee you it's gonna work more times than not. So yeah, this one I was like, oh, can we use a hash map? And he's like, oh yeah, yeah. And I was like, oh, okay, wait, okay. And I tried using a hash map for this, and I ended up getting it. So and then the and something funny. So this is the problem on LeetCode. the the follow up was the follow up was the hard version of this, which is basically duplicates are allowed. Uh, and like this is the code for it. But I yeah, I actually didn't do this prior to the interview. I had to do it in the interview, and I knew it was a hard while I was doing it. So I was like, I thought it was like over, but no, man, I got the offer. It's okay. But yeah, that's I would show you guys how to do this problem, but it's not enough time. Anyway, does everyone understand everything we've done so far? Yeah, good. Any questions? No questions. All right. If anybody you like have questions, it's just like if you guys are interested like working at Bloomberg or something, I'm happy to like just tell you about my process, how it was, and yeah. Thank you for that. Yes. Yeah, yeah, 100%. Yeah. So like we're ending. So if anybody has to leave, yeah, I'm not forcing you to stay. Thank you for coming here. But yeah, I'll talk about my Bloomberg process. So are you guys familiar with Code for All? Yeah, so the president, right? He interned at Bloomberg last summer. He did really good, right? And basically they were like, "Oh, if Queens College have more kids like this, let's go there." So then they came, they had an event here, and it was like capped at 40 people. And basically if you went, you basically got a special link to apply. Like guaranteed interview pretty much. That's how I got my link. So I applied. I applied in September. I got my first interview November. No, I had my first interview November 5th. It was just one tech. So first 10, 15 minutes was just talking behavioral. And then last like 40, 45 minutes is technical, and like last 5 minutes is just if you have a question. My technical was this question I just showed you. This was my first technical, okay, and then I had my super day, which was scheduled a month later, December 11th, and basically super days work like this: if you do good on like the first interview, then you'll get the second interview. If you do good and if you do bad in any interview, they're just gonna cut you off. So they just send you home. So I had my first interview, my of the super day. It was this question. It was, and then the follow up was the LeetCode hard, and then yeah, you can take a picture, 100%. Uh, yeah, this is so this was, and the follow up was LeetCode hard, right? And then I had my, and then he was like, "Hey, are you free in an hour?" And I was like, "Yeah." And then I came back for the second technical of the day, which was just it was a heap question. It was really easy. It was like find the smallest, second smallest, and kth smallest integer. It was a pretty easy question. It was 3 points. And when he said that, I was like, "Oh, I'm in." But anyway, there was that, and then he was like, "Okay, are you free in an hour?" And then I had my HR round, which was a 30 minutes of just talking about what I expect at Bloomberg and stuff like that. And then I scheduled my engineering manager round a week later, December 18th. It was just an hour talking with the senior engineering manager. I got super lucky because some of these engineering managers, they ask crazy stuff. Like they'll ask you like networking stuff, like what's TCP? How is TCP better than UDP or stuff like that, right? I I'm a sophomore, so I haven't taken any of that stuff. So like I was like, if I get asked something like that, it's over for me. But my dude, he was like, I think maybe it's because I did really good on the technicals beforehand. I don't think he felt the need to grill me on my stuff. So he was like, "Hey, I'm not gonna talk to you about your resume or anything. I just want to talk to you." And me and him just talked and had like we just had fun for an hour. And then I got my offer January 7th. Yeah, yeah. So I can actually put my resume. Um, all right. Uh, so this was my resume. Nobody grilled. What? Yeah, that was my website. Yeah, yeah. So nobody nobody grilled me on my resume. Like nobody asked me anything on my resume. I think it's partly because I was able to just talk to them. Like because I feel like the first 10, 15 minutes is a behavior, right? If you can just talk to them and answer like their questions and just talk, you know, I feel like the resume is like a fallback. If there's nothing for you to talk to them about, they're gonna start asking about your resume. And that's advice because I was even if they were to ask me about my resume, I know how to explain every single thing on my resume. I know my resume inside and out. You know, don't ever have something on a resume you can't explain because then you're gonna look like you're gonna look like stupid if like they ask you a question and like you just so just know your resume inside out. So I knew my resume inside out, but like fortunately, I guess then nobody asked me about it. Um, I just talked, but for me, like when I introduced myself and stuff, and I just started talking about my experience at Dot Dash Meredith and IAC, and then I didn't talk about Morgan Stanley because at the time I was Morgan Stanley was a winter internship. I did in the winter, so I didn't do it at the time, and I don't want to say hey I'm incoming at Morgan Stanley because I felt like like it was unneeded information. So I just talked about what was actually on my resume at the time, which was Dot Dash Meredith, and I didn't talk about my projects. I just talked about because they companies care more about experience than projects. So yeah, I was working at like I'm not sure if you know like have you heard of like People magazine like yes that's what that Dutch Meredith is, right? I worked on People, their website. Yeah, yeah, metrics, right? So right, so I just asked my manager. I was just like, hey, I need like, are there any metrics I can have like on my resume? And then me and him just sat down. We went through like literally Google metrics like that was hooked up to People and stuff, and we just looked at that, and he was like, hey, okay, your work is doing this. Let's make that okay. And he was giving me percentages, and he was giving me numbers to work with. So yeah, I'd say like at the end of your internship, you like if you get one, just talk to your manager. Like ask them for stuff because I'll tell you right now, most managers in tech in my experience at least it's a very sheltered experience but like they're like super chill, they're like awesome. Just talk to them and like yeah they're gonna understand, right? They know metrics are important, so Bloomberg for yeah, so I actually didn't know DSA until I started DSA August, this last August. After Dot Dash Meredith ended, I was just at home and I just like felt so lazy and like stupid doing nothing. So I was like, you know what? Let me learn LeetCode. So I started in August. I'm a sophomore, so I hadn't taken I'm taking DSA right now, 313. So I just started following a roadmap. I'd say when you're learning LeetCode for the first time, follow a roadmap. I recommend this if you're completely new. Do this. Use AlgoMap. AlgoMap is a really good roadmap. It's way more beginner friendly. They ask way easier questions. Yeah, yeah. Take a picture. Go ahead. Yeah, yeah. No, no, 100%. That's why I'm here. Anyway, so yeah, this is AlgoMap, right? I feel like this roadmap is a lot easier for beginners. After you can like make it through this roadmap, then you get onto the goat. You get into the guy, man. This guy saved everyone. But anyway, yeah, you go into LeetCode. LeetCode's roadmap. I guarantee you, if you could answer his 150 questions on his roadmap, you are ready for like Google. You're ready. You're ready for big tech. If you can, yeah, yeah. I finished most of it. I finished. Yeah, I started in August. I basically grinded LeetCode up to mid December, like my final super day, so December 11th, and then I stopped doing LeetCode, so it was like 3.5 months. But I had a pretty easy semester last semester, so I was like doing like, and I was like really motivated because I didn't want to lose Bloomberg. So I did like I was doing like 5 hours a day. I don't want to think about it; it was too much. But no, no, no. Right, right, right. Exactly. I'd say my biggest advice for LeetCode: do not chase numbers. Don't just chase. Hey, I have to do 200 problems. Chase understanding. Do under. I'll tell you right now. I've done like 400 problems, but like I wasn't chasing 400. For me, it was like, hey, I want to just understand the fundamentals. I want to understand the basics. And then after you understand the basics and you understand like data structure and algorithms, then you can just move on. It's fun. It's LeetCode's fun because now you know how to answer these questions. Like, so I'd say like just just chase understanding, really understand the fundamentals, grasp it, and you'll be fine. Like I'm like the new LeetCode tutor workshop. The previous one, He's now a Google software engineer. Yeah, and he's so I've done 400 problems, right? But he only did like 120. Okay, he only did 120 legal problems. But the thing is that like I'm kind of just doing them now for fun. Okay, and like there's no point in me like really doing them. I'm just but he when he was doing them, he did them for understanding. Like he those 120 problems he fundamentally understood them, and because of that, he was able to get through Google's process, right? So that's what my biggest thing. Don't just chase numbers. Don't get caught in the idea of I need to do this much. I need to do this much. Just just understand everything you do. And if you don't understand the question, come back the next day. You know, like there's no shame in looking up a solution, right? But like don't gaslight yourself into thinking like, I understand this, and you move on. You know, if you looked at the solution, come back the next day, do it again. If you can do it from your own memory and like you understand and like you can actually do it, then that means you understood it, right? That means you can move on. But if you didn't, that means you didn't understand it, meaning that maybe there was something in the algorithm you didn't understand. So then you can try another problem like that, and then do it from there, right? That's how you build that understanding. It's just LeetCode is not intelligence based. It's pattern recognition. It's repetition. Everybody like everybody can get good at LeetCode. You're not and that isn't that like so nice because like these top paying companies, Google, Meta, Bloomberg, they ask LeetCode, and this is something you can study for. Like you can study this. You can get better at this. If you don't do LeetCode, you're not gonna be good at LeetCode. So like it's so reassuring. Like so yeah.
I have two questions. One was, what was your balance between, like, how many classes were you taking when you were running the lead code?
So I was doing 15 credits last semester, but to be fair, like two of the classes I didn't really go to. And I'll tell you this, right? Everything in life is trade-offs. My GPA did like it didn't tank, but it did get like a little worse because I wasn't studying. Like I was going to linguistics just to do lead coding class. Right? I wasn't paying attention, and there's trade-offs. There's trade-offs. Like you know, and like it worked out for me, right? Because I ended up getting the offer. But it's just it's like so I wouldn't say like yes focus on your studies do good in school, but it's like it in my opinion, like if you want to be a software engineer, like stuff like this should be taking a bit more priority than school. So I'd say like balance, just like just give and take. Just do it where you can. Just my idea is like take it chill for like the first, like if when you're learning, take it chill. There's no rush, because like this cycle is not, it's like mostly over. So like now you can just be, if you're doing LeetCode now, you're prepping for next cycle. So you have a lot of time for next cycle. Like Google and stuff, they start recruiting like late summer. Okay. So you have time for that. So like I only had 3.5 months and I had to like really grind it out, right? Because Bloomberg was right around the corner. But like you guys have time. You guys can take it chill, and then as interview season starts coming up, you can just start upping the hours. Like start doing more.
Okay, and that kind of connected to my second question was like, okay, because I went to this past hackathon, the Hack Night.
Hack night, yeah.
Now the thing is, I had got invited to interview with Bloomberg,
Yeah.
and I essentially bombed it because I didn't. To be fair, I did get the interview invitation on short notice, only a couple days prior, and before then I was grinding in my other classes, like one of my math classes, and I was catching up on another class, right? And so I guess the point of my question is like, if I bombed that interview at Bloomberg, what are the chances that they would give me another shot to try?
But Bloomberg, so my impression of Bloomberg is they're really big on this is so okay. So the way it is basically if you like do bad, like if you applied once and you like do bad, there's a 6 month wait, and then after that 6 month wait, then you can apply again. So you can actually recruiter for, is your like recruiter like Vicky Anna or something, or like Karen?
I think Karen is the recruiter, but Vicky Anna was the one who invited me to the
Yeah,
interview.
yeah. Karen's the goat, bro. She's my recruiter. Yeah, she's awesome, best. But yeah, I won't worry too much about it. Like Bloomberg's a good company, 100%. Like, of course, I'm gonna say that, but like, there's like so many other companies out there and stuff. So even if Bloomberg is like not in like if it's not like it shouldn't be like end all be all, right? It just honestly, just winning a software engineering is just landing a software engineering job in this market, right? And from there you can just work up, because once you get that experience, you can get into senior level positions and stuff. Like it's pretty cool. So yeah, don't be disheartened by that. Plus, you only had like a couple of days, right? I had like a month to study before every single interview cycle, right? So it was that. If like I said, like stuff like Bloomberg and like these stuff, like if you if you don't like grind it out, if you don't grind out the questions on their tags and stuff and just work at it, then like you're not gonna have a fighting chance. You only had a couple of days, so I wouldn't be so like disheartened by that. Yeah, yeah. I'm a sophomore. Yeah. I will tell you, if you're on like CS majors on Reddit or something, you're gonna always see that stuff, right? Don't pay into it because I'll tell you this, right? Look, there is a lot of people in CS market, but I guarantee you, most of those kids they don't know like I don't want to say like they don't know much, like they're not competition. The competition is still the same. Like you still need to have a base number or not. Just I'll tell you this: know your stuff, like network. Like everyone always says this, right? But, like just know your stuff. Like that's number one thing. If like because people know, like I'll tell you right now, these interviewers they know like Ming. Can I drop? Like, can I curse a little bit? This is so okay. Like interviewers know who's a bullshitter and who's not. Like they know this stuff. They could like kind of smell it on you, right? But if you like know yourself and just talk to them, and also like along with knowing yourself, like just be personable. If you're looking for like new higher positions, they want someone that they can work with, they can teach. So just be personable. Don't you can be literally like a LeetCode monkey, like crazy LeetCode. But if you can't talk, no one's gonna hire you. So that's just the big idea. Just have good projects. Just grind LeetCode. And just honestly after that just pray because because it's RNG. The entire market is RNG. Like I like me getting like because what happened? I applied to Bloomberg the first time. I applied with the wrong email and they rejected me. And I applied with the right email and then I ended up getting like going through the process and getting the offer. But it was just like I got super sad about that. But it was just like RNG. Just try what you can. If you guys are in Code for All, there's a bot in Code for All, the internship bot. It just drops internships like every day, like every day. Just apply, man. Like Code for All. Yeah, it's like it's literally I think it's the biggest CS club in all of on campus. I think like even CUNY in general. Yeah, you should definitely check it out. I think you can hit up you can ask Ming for like the Discord after. Hmm? I do not, but maybe you can help afterwards. But yeah. So yeah, definitely like join that, be a part of that, and like everyone's code for all popping up. Like President Bloomberg, one of the guys who used to be code for all member, he board Google. There's like there were like two people got C1 today, Capital One, like software engineering offers. Like it was like it's crazy. I'm telling you, like you should like join code for all, be active in there. People, it's a different environment. So just be out there. Yes. Like so projects are stuff you talk about in the interview, right? Like that's saying, hey, I have experience with this sort of technology and stuff like that. So that's something you talk about. But like online assessments and stuff, like they don't know that, right? Like you just have to do the problem. Like you just have to, which is DSA. Yeah, yeah. Do if you guys want like good cool projects, go to hackathons. You'll do cool stuff, and you also meet really cool people, and you'll network with them, and like you can make teams of that. Me personally, I've never done a hackathon. So maybe one day, but right now I haven't done any. So, but yeah, I do recommend hackathons. I especially like Hack Night, like our this the Hack Night we just had for this spring, super big. It was like they were giving out like we the Nintendo Switches and stuff. It was like a really we were sponsored by Bloomberg and Capital One, So and like yeah, it's coming back. It's gonna happen in fall. It's gonna be a fall spring thing. So definitely look out for that. And yeah, just talk to people. That's the number one thing. But
Quick question about the like that tree graph you showed earlier.
yeah,
With that, like, when going down the branches, um, I guess those are just for fundamental, because what I'm trying to ask is like, okay, because I like coding in C++, and I guess would it make sense to focus on certain branches more than others if I wanted to go down a certain career path, or is this just all fundamental
This is fundamental stuff. Honestly, it's just start at the top and then work your way to the bottom. It's just different data structures and algorithms. It's like you're gonna need to understand arrays and hash maps if you want to do dynamic programming, right? If it's down over here, oh, it's not even. It should be, but so if I just go to roadmap, like dynamic program is like down here somewhere. Well, yeah, 1D right? Like you're gonna need to understand arrays and stuff. So just basically, the roadmap is basically made by someone who had to learn LeetCode like the hard way. Like you had to learn like, oh, well, what makes sense here, like which is intuitive. So just work your way down. So like start with arrays, then go to two pointers, then go to stack. It starts easy and it gets harder. Like it builds off. It builds off it. So yeah, there's no specific like questions you would have to do for a specific software engineer. Like I mean, I guess for data analysts, like if you want to be like a data engineer, they ask like SQL LeetCode questions. SQL isn't really on this list. This is more just actual like algorithms and stuff. So if you want to do like data engineering, maybe check that out, the SQL stuff. But other than that, like this is just a really good roadmap in general. You know, like I preach it. If you even if you're not doing like tech, leak code is still important. Like you should do it, even if you're like an English major. It's problem solving. It's good. No, no, I didn't pay. I didn't pay for this. No money, no money. Yeah, no, no, no. You only if you pay, you only get like his videos, which are really helpful. But like he still has videos explaining every single question on this list, so which is free. So
Wait, so what did you just say about those videos? Like, what do you access?
oh, so when you pay for pro, you get access to like his his courses, like his courses, which is bringing like basically teaches you like a baby pretty much. But you guys don't need it. Trust me. You guys just start like don't do Nico first. Do Algo Map first. Algo if you're starting Nico for the first time, Algo Map. He has like a video to show you the data structure algorithms, and then you can just do the problems from there. Yeah, yeah. I mean, we'll probably announce Alco for all. Yeah. It, yes. Yes. Okay. No more questions. It was really nice meeting everyone.
So one more question.
It's cool.